G'day. Hey there. Okay, here's a brief discussion of what we're going to do. There's going to be an intro where I explain what several words you've already seen mean. We're going to talk about modern software engineering practices, which you should all pretty much know, but I'm going to mention them because otherwise there'll be no explanation as to how we had to spend so much time introducing them where they weren't there before. Attracting a developer community, which should also be very obvious. Finding and fixing bad practices. This is where roughly half my talk will go. This is like an enormous cookbook of stuff that is bad that you should fix. I should also mention I have approximately twice as many slides as I have time to present. So if you like something or don't like something, let me know. War stories. They insisted that when I proposed this talk that I include war stories. So there are some war stories. They're actually amusing, so I'll try not to skip those. And then some stuff at the end, which is for people who read the slides later. Intro. So I've been doing Unix for far too long now. I should really get off and do something else. I used to work for SGI, did NFS stuff. Now I work on Cyrus, a fastmail, which is all completely different. So what is fastmail? It's not actually a radio station. The FM stands for Federated States of Micronesia. I'm sure this was a good idea. So we are a small Australian web email provider that's been around since 2000, and we got bought by Opera last year, and very soon after that I got hired. And we have and the reason I got hired is because we have a brand new fancy webmail thing that now powers Opera's webmail offering, which they are selling to people. So, and there's all the wonderful webby, emaily features. I don't work on any of that stuff except I do the back-end things. What is Cyrus? It's an IMAP and several other protocols that don't matter. Email server, which stores and manages email. It's open source. It's from Carnegie Mellon originally, and it's a BSD-like license. It's almost exactly the 3-clause license with an extra clause they're putting there to confuse you. It's written in C. It runs on Unix systems. And the version control system dates go back to July 93. So it's not exactly a spring chicken. How did it get so dusty? Well, 3 main reasons. The first is any sufficiently old program just bit rots. That's just a fact of software. Also because it is actually so old, it was written before a whole bunch of the stuff that we use to write software today and to make software work better today was invented or widely known, and in particular C89, C++, Java, object orientation, test-driven development, Purify, Valgrind, MIME, Unicode. All these things were glints in the eyes of various standards committees when this stuff was written. And thirdly is the actual domain that we work on is a maze of twisty little RFCs, some of which, and IMAP is my particular favourite, are enormously funky. And how funky? That's the email RFC jungle. Lovely, isn't it? Yeah, it's awful. There's dozens and dozens and dozens. Anyway, Fastmail and Cyrus. So Fastmail use Cyrus to store customers' email, which means it's actually important that it work and work reliably. And so as part of that, when you rely on open source software like that, is you really have to be part of the community and foster the community. And in the case of Cyrus, it had kind of drifted off into obscurity and the community had kind of died out. And so Fastmail had to help resurrect the whole community. And there's a whole bunch of really good practical reasons why you want to do that. I mean, when the code's renovated, there are less bugs simply because the software works better. And the mere fact that your code looks modern attracts developers, which means there's less bugs, which, yes?
Just one thing, at about the time it sounds like this was happening, Dovecot had become the new fashionable IMAP server.
What about Dovecot? Yes. So, good question. When Fastmail was founded, Dovecot didn't exist yet. So they started with Cyrus. And there are also other reasons which have been explained to me as Dovecot has a storage abstraction layer, which therefore has to be slower. I don't know Dovecot. I don't know if this is true. This is the justification used. I think the real reason is historical, frankly.
And it's paying your salary quite nicely, so you're very happy with the decision.
Well, it's paying my salary quite nicely, yes, thank you. I would have worked on Dovecot just as well. I was just as ignorant of either of those when I started. So a few years ago, Bron Gondwana from Fastmail started pushing Cyrus, and he's like one of the big maintainers in Cyrus now. And then I got hired, and this talk is his experience and mine put together. So we haven't just been maintaining, there's also been feature work. I'll talk about that some other day. Modern version control, modern software engineering practices, distributed version controls. This entire slide comes down to use Git. Making testing happen. You need to have a system test suite. You need to have unit tests. They have to be different things. We have to explain this to people every now and again. Having unit tests often forces you to refactor the code for testability. This is a good thing. Having a test, use a test framework. Don't write your own test framework. I know it seems easy, just don't. Because none of them are perfect. You're going to have to work on them. But if somebody's written the first 50%, you win.
Not Invented Here is so fun.
Not Invented Here is so fun, yes. Fixing other people's broken code is even more fun. That's what I do all day. Run your tests often. If you have C code, run it under Valgrind all the time. Just don't. It doesn't matter. It doesn't matter. It's slower. It doesn't matter. It's a test. It doesn't matter. Maintain your tests. So make sure that the things run. Every now and again, the test breaks. Deal with it. Do coverage studies and improve the tests. I have another whole talk about coverage. That will be for another day. Making testing happen. Thank you. Test-driven development. This is a good thing to practice, although you don't have to swallow the entire agile red pill. Fundamentally, what it means is every time you address a bug or a small feature, you start by writing a failing test case in your test suite that you already have. This is, of course, where never mind. Then you fix the bug, and then you show the test case passes. Like all software methodology things, there's an element of fantasy, but if you stick to this as the basic the basic premise, then it actually works well. The other thing is that there's a social aspect to this. You need to nag people who do things like update the code to change APIs, but don't update the tests. Break the test by breaking code. Don't write regression tests when fixing bugs. And people lapse into this because all these things are unnatural behaviors for people who like to write code. Now, for our unit tests, we use the C unit test framework, and really the only reason we use it is because it works in a C-only environment. Every other C-like unit thing requires C++ at some point or another, and we just basically weren't brave enough to try and make this open source project require C++. So, yes, it's very stable, and there's a whole bunch of things about it that don't exist, which I had to add. That stuff's all on the in the Cyrus Git repo. You can have a look. But yes, it's almost useful, I think. The Perl test unit framework, we use this for our system tests. It's a lot better, but we still have to do some stuff on it. But as I said, if you start with somebody having written most of it for you, win. Cassandane is a thing that I spend an enormous amount of time on. It's our system test suite for Cyrus, which didn't exist until I came along, because there were no system tests for Cyrus. It's written in Perl, it uses test unit, and one of the things it does, unlike a lot of server tests that I've seen, is it creates and manages temporary instances of the server. So you don't run it against an existing server. You run it, it starts up a server, and what this allows us to do is to have an enormous amount of precise control over the server config, and it also means that every test gets a blank slate, a known initial state of the entire server, which is empty, but sometimes for some tests that's good. It means a lot of tests have to do things like create a bunch of messages and load them up before we can do anything useful, but at least, well, we have all the utility code to do that for you.
Sam's got a big problem with one test influencing another one later, but our initialisation is too slow to redo it.
Yes, well, fortunately our initialisation is fast enough that we can do these things. And also, the other reason for this is that we have a lot of really interesting server configs, like multiple server configs, like there's a thing called a murder, which is a I'm sure somebody loved crows for some reason. It's a cluster. And there is proxy configurations and replication between these things and all sorts of interesting configurations of multiple servers. So yeah, the test suite needs to actually create these things. It uses Perl client code like mail IMAP talk, which one of our guys wrote, which actually talks to the servers that it started up and does things to them, and then tests that the result was good, and tests that there were things like there were no calls afterwards and things like that. And there's an option to run everything under Valgrind, which is used all the time. Bug tracking system. I shouldn't have to tell you this. Use a bug tracking system. Bugzilla is okay. Jira is okay. They all suck. They're good enough. Just use one. Doesn't matter. And you need somebody whose job it is to actually make sure that things get updated. Otherwise, nobody does it. So, coding standards. Surprisingly, maybe not surprisingly, you need coding standards. Really, you need coding standards. And you can retrofit them into a project. It's just a question of detecting what the effective nominal average consensus of the coding standard was. In other words, the least amount of stuff you're going to have to fix to actually achieve your coding standard in practice. It needs to be very well documented and needs to be stuck to write in indent.pro. Very useful trick. It means that's in the actual version control system. So anybody working on your project can just run indent on a function, whatever, and it comes out the way it's supposed to. So there's no arguments. And if your coding standard is not expressible in indent.pro, you are doing your coding standard wrong. You should reformat code to achieve them. Don't mix reformatting changes with functional changes. You'll hate yourself. Continuous integration, my new favorite toy. So the idea here is that you build and you test your entire system on every single commit, or at least some loose approximation of every. I like Jenkins, formerly known as Hudson. It's good for a whole bunch of reasons. There are others. I'm sure they're all fine. Doesn't matter. So we've been running on hudson.cyrusimap.org for 6 months with kind of mixed results. There's been a few little problems actually getting that to work reliably, which is why I haven't actually been CCing the mails out to the public devel list. But yeah, and what I've been doing in the last couple of weeks actually is just trying to make it run the Cassandane system tests. So we have well over 400 test cases in there now, only 100 of which fail. Attracting a developer community. This is an open source crowd. I shouldn't really have to explain this, but nevertheless. Have a website. Don't make people write in tilde when they want to find, there should be no tildes, no source forges. You need an actual website, yourprojectname.org. And if your project name is hard to do that with, maybe you should consider changing your project name.
People go there first anyway.
I'm sorry?
People will go to that anyway. So
Yes, people will be going to yourproject.org now, I'm sure. I wonder if there's anything there. It's like example.com. I'm sure somebody has some kind of parking thing on there.
Example.com is perfectly reserved for examples.
Really?
There's an RFC about that.
There is an RFC for example.com. Maybe I should write an RFC for yourproject.org. Do you think they'd accept that?
Yourproject.org is for sale, apparently.
Who's got a credit card? I should advertise them, mate. Yeah. There you go. Okay. Separate stable and release branches. Just sensible project management. It should be obvious. Regular releases. This is actually things that we had to, Bron had to before I turned up, reintroduce to the Cyrus team. They'd got to the point where they hadn't introduced any kind of release for several years. We now have the point now where we have a release every few months, sometimes every few days, where interesting things happen that I'll talk about later. And you need downloadable release tarballs. All this stuff's on cyrusimap.org. So you can go and see all these things. Play well with others. Be nice to people. I shouldn't have to say that, but there may be kernel people here. This is the current Cyrus community. So as you can see, as in most open source communities, there is a small core and a whole bunch of people who do things from time to time. The bad practice cookbook. There's lots and lots of these. how do you find them? First up, there's a number of ways. The first thing I always do is just turn on GCC warning flags. GCC does a lot of work for you. It's all off by default, of course. My favourite's Wall and Wextra. You should start with those. Wall used to be a good name many, many years ago. Now it's just the basic stuff. W-Extra is effectively the basic stuff. It's W-strict prototypes. You shouldn't need that, but we did. Minus W pointer arithmetic, also needed. And W write strings, that found us some interesting bugs too. And you need to do these things the minus O something, where n is greater than 1, because some of those warning code doesn't even run in the compiler unless you actually have optimization on. Coverity scanner. I think this is really cool. Coverity make a static source code analysis program, which is commercial. They are paid by the US government to do a hosted service for open source projects. It's easy. You go to scan.coverity.com, you walk through some paperwork, which is just boring and takes a few days, and then they run this thing on your code, and you get an enormous number of reports, most of which are completely false positives. Most of which. In our case, it found a remotely exploitable vulnerability. More on that later. It's entirely possible to find another one when we finish going through the thousands of reports. The hard way, grep. Writing custom scripts and just using the code, looking at the thing, just with a magnifying glass. Now, I have a classification system for these danger signs. The danger tag indicates a bug that's waiting to happen, possibly something that's actually a security hole. You should hunt these down and analyze them or replace them as a matter of urgency. Ugly is just stuff that needs replacing. It's the linoleum of code. Probably still just works, just ugly. And better is stuff that works fine, even looks good, but there are smarter ways of doing things that actually have some useful practical effect. Now I have far more of these than I can go through in the time, so I will either skip or talk about things in some detail if anyone actually bothers to care. Realloc. I hate realloc. They should say it's brilliant, it's really useful. Using it properly, not so easy. If your code has calls to realloc in it, the chances are it's not being used properly. I'm sorry, was that a comment? Just a beep, okay. So what I do is, one of the first things I do when I look at a new piece of code is find reallocs and replace them with actual calls to some kind of library that is actually separate and well tested and does useful things. An expanding string library is particularly useful. The same argument goes for memmove and memcopy. Again, the downside of getting it wrong is crashes, remotely exploitable buffer holes, all kinds of stuff, bad stuff. Here's an example of some stuff we did. Oh, realloc. Well, look at all that stuff that's hard to do and hard to get right. Well, if you just use the library, it's got it right. Sprintf and strcpy, these should never have existed. They're wrong. Do not use ever and get rid of them. The usual advice with them is to replace them with the explicit boundary check version, strncopy or strlcopy, if you're on a platform that has that.
What about
ASPrintf, otherwise known as I like memory leaks.
Sprintf with a size limit on the...
SNPrintf. Yes.
Can't you add one to the %s?
Oh yeah, sure you can. Yes you can, absolutely. But that's a size limit on that particular argument. What you want is a size limit on the buffer it's going into. And if you only have 1% s in the entire thing, there's a reasonably easy calculation. But if you don't, Anyway, you shouldn't be doing the calculation. The whole point is, if you're doing the calculation, sometime you're going to get it wrong. So here's a nice obvious example, which is replacing a sprintf to a buff with something that includes a %s. So it's, you had no idea how long that string is. With SNPrintf that passes in the size of the buff, which is great. Except that what happens when you overflow? Well, you get an unterminated string and a return value that you have to check against size of buff to see if that happened. Or you can just blat the last byte of the buffer with. But this isn't any better.
Isn't printf's guaranteed to null terminate the string?
I'm sorry, my bad. I repeat my comments for string copy. Regardless, those functions are really not much better. And lcopy is like, why am I passing in size of buff every time? It's tedious. So the real solution is use a good expanding string library. And we've done a lot of stuff improving the expanding string library that's in Cyrus and using it in a whole bunch of places. There's still a few like this. This is a synthetic example. The actual code doesn't have this one. Malloc and Stradupe are great. You can't live without them. But they can return null. Many people don't realize they can return null because it never does. It never returns null. It never happens. And the thing is, some people do realize that it returns null and check it, but never test that because they don't have a way of making it return null. So you have two options. Either you have code that doesn't exist that will make your program behave in bizarre, unexpected ways when it runs out of memory, or you have code that does exist, probably doesn't work, and has never been tested, and drags down your test coverage stats. None of these options are good, so the only sensible thing to do with malloc is put it in a wrapper that just never returns null because it logs and exits if you're out of memory. Of course, logging when you're out of memory is a whole interesting thing to do, but you only have to write that function once. Xmalloc, of course, is a famous traditional old GNU thing. If you've ever looked in GNU code, this idea is very, very old. The same thing applies to Stradupe, realloc, anything that can allocate and return memory. You should have a wrapper for it that handles in a sensible way. So I did quite a lot of this kind of housekeeping. Open-coded data structures, sure, you can write a hash table, don't. Open-coded crypto, really? We actually had our own open-coded MD5 in Cyrus at some point. That seemed like such a good idea. Error muddling. I can actually talk about that one all day, so I won't. Printf-like functions. GCC has this wonderful attribute format printf. Use it. It finds bugs.
You can do compile checking with them.
I'm sorry?
You can do compile time checking with them. Just the directive to GCC says it's a printf like.
Yes. I'm sorry. Yes. When I say this defeats normal compile time checking, it defeats the compile time checking that's in the C standard. GCC, as you rightly point out, has its own way of checking printf arguments, but it doesn't even try unless you give it the right magic, which is the attribute format printf. That magic has to be there. And you should use it. I highly recommend it. I think it's an excellent feature of GCC. I'm sorry?
We went through that with Sam as well.
Yeah, it's always worth it. If you find 1 or 2 bugs out of your 300 or 400 calls to such a thing, it's worth it. And it's basically free. You do in one line.
Format string attacks.
Format string attacks. Oh yeah.
And that's the main reason we did it, because we found that not
Sure.
that's done.
Sure. There is a real security impact to that. That's right. If you have any kind of network-facing server, like Cyrus. Ugly. It's ugly time. KNR functions. No, really. There is actually. I checked in some code 4 or 5 months ago that actually removed the last KNR function definition from code that's actually compiled into Cyrus. There is still one in there, but it's only compiled on BSD, so that more or less doesn't matter to me. I'm actually kind of surprised that's still legal in compilers. It's like so ugly, so wrong. Same thing applies to varargs.h. I found several of these. They're dead now. Other relics of KNR C to C89 transition. If def stood C, there's no reason to do that. Seriously, that was 20 years ago. Just don't. Const uncorrectness. People have differing opinions on constness.
Const only works if you can unconst.
Const only works if you can unconst. Yes, well, fortunately in C you can almost anything. So I think fundamentally const is at best a hint. But nevertheless, I think it's a useful hint, and it's a useful hint to humans as well as to the compiler. I always, when I write new APIs, put as much const in it as I think makes sense, because it just helps it make it obvious. And in this case, the key is a string that isn't modified, it takes a copy. That const helps you recognize that just by looking. Right? It's a useful thing. Free of null. If you used to pass a null to the free function, it used to crash. It doesn't anymore. It's in the man page. So if you see code that does this, and there's a lot of this really careful code, if x free of x, they're doing the useless half of the job. What the code should actually do is free of x equals null. That's actually the sensible thing to do, but I'll talk about that in a little while. Global functions. Because in C, global is the default, which is arguably another one of C's greatest mistakes. You can get all this rubbish in the global name table. I just like getting rid of it. There used to be like a technical argument. Linking will go fast. Oh, not really. It's just tidiness, really. Yeah, it's a taste thing. Bit symbols. Oh yeah, collision. Yeah, you can get ugly things happening with those. We didn't have any of those because all that code was so old, the bugs had been worked out. But that's not an excuse. Bad symbols. Again, this is one of those taste things. I personally prefer to have vowels in my symbol names and underscores. You may differ, but vowels are good. Yeah, vowels are good. They used to be expensive apparently in Unix. If you look at libc, there was some kind of global vowel shortage. Maybe a vowel factory in Thailand had flooded or something. Yes, there was a limit. There's always an excuse. So I would say that similarity with a libc function that does a similar thing, which is actually an argument that was made for making this particular function called system, is a non-starter. libc has requirements, historical compatibility requirements that you don't have. Deal with it. Also, I have this little grammatical thing. I insist that there's actually, well, this is actually probably a bad example to show you, but I really like to have function names with verbs in them. Because the function does something, a verb is a doing word. And of course, every now and again, somebody writes some code and it has one of those words where, like count. So count is a verb or a noun, depending upon, what does that function do? I don't know. Obviousness is the goal. Okay. White space orthodoxy. This is a matter of taste. So there's this thing with the Linux kernel where they don't like patches that add weird white space or bad white space, and there's several different definitions of what bad means, which is really a coding standards issue. And because the kernel folk basically like to be able to read patches, and using a tool that gives you a graphical display of the patch, which would make the white space difference be completely meaningless, they can't do that. And because the kernel person wrote Git, Git now enforces that particular taste. And so if you do a commit that adds what it describes as bad white space, it gets all whiny about it, and that's never a good thing.
Wouldn't you just use indent to get the white spacing right?
Yes, indent would give you the white spacing right. This of course assumes that people run indent. But yes, I personally only run indent when something is really egregiously wrong.
Well, I run it all the time. I just don't just type stuff in and run it. sort it out.
And you should be able to just run it all the time. If your indent.pro is right, that should be an easy thing. Again, that's just my personal taste. So what I do is I use a set of Vim macros that I got from Keith Owens and modified a bit, but there's at least 2 of these on GitHub that you can Google for that basically turn bad white space lovely and red, and then you can go and be really annoyed every time you look at someone else's 10-year-old source code file and remove them. I've done a lot of that. Duplicate code. I shouldn't have to explain this. These are the 3, when I say 3, of course I mean 4, because the middle one had 2 completely independent copies. String structures that we had in Cyrus. The first one is gone. The second one is scheduled for immediate deletion. Fortunately, that's only used in a couple of places. It's actually removable, and it was a very simple one. This last one, all the useful functionality of that is now, yes, we've just been expanding it, and it's now actually a useful string class. It does one thing that I've never seen in another string class, which it actually has a copy on write feature, so you can set it up to point at constant data, and as soon as you actually do any operation on it that would change it, it makes a copy. This is actually quite useful. Okay. Share the horror. I would posit that any function with more than 5 arguments is wrong. This one has 15, I think. Maybe somebody can count it, whatever, it's awful. We haven't got rid of this one yet. They're just hard to understand. I mean, I shouldn't have to explain it to anyone.
It would look slightly better if you kept 1 argument per line.
Yes, it would look a lot better if it had been kept with 1 argument per line and left justified. Unfortunately, our coding standard gives us this. Our consensus coding standard. That works really well for functions with 1 argument. Like I said, the coding standard came from existing consensus, not my taste. I just wrote the document. Magic numbers. I should not have to explain this either. Okay, single error path. This is a better thing. This is where you have code that works just fine, but there is actually a way to do it that is arguably practically better. And this is taken from the Linux kernel style, and what it does is you put all your error handling in a single block, usually at the end of the function with a label out, and almost all your error handling in the function does go to out, sometimes setting an error variable first. Which means you only get to write error handling once, well that has to be a bit more general, but that's usually not that hard. It does of course mean you have to initialize variables at the start of the function usually, but it makes error handling less tedious and less inaccurate. I think so, and I've rewritten code to look like it. Here's an example. This is actual code out of Cyrus with approximately half of it chopped out for clarity. So the key things here are, oh yes, you initialize your return variable, and at the end you return the return variable, which is an error code. You have this out block here, and it deals with both the something got initialized in here and not cases, which is in a known state regardless of how you go through the function. And the actual error handling here just basically does whiny, 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 go to out. So as opposed to the usual thing is you do close things, close that, close something else, all of that in there. Of course, this is a wonderful way of breaking running code, so be careful. Straconcat. I love Straconcat. Straconcat is something that this idea I pinched from the glib library, the GNOME glib library, and what it does is it takes a varargs list of strings, works out exactly the right size, and gives you a string which is the concatenation of all of them. You'd be surprised how amazingly useful that is. Strcmp safe. It's like strcmp, but it doesn't crash if you pass it a null. It just treats null as an empty string. Yes, the number of, that would have been so easy. Yes, anyway, we use that now. We're very happy with it because we don't like crashing. And almost all the time, when you have a null, you really want to treat it as an empty string. It's like you want to treat them as more or less equivalent. Sensible languages do almost that. The one thing you don't want to do is crash. Yes, well said. Str-array-t. You'd be surprised how common an operation it is to have a length of a set of strings and do things on them. and to have a library that basically gives you something that you can feed as an argv into execv or do other useful things with. Very, very useful. Highly recommend getting one. This is some actual tokenizing code that got replaced with this single line that does more or less the same thing. You'll see lots and lots of stuff like this where the code gets a lot smaller. Now, I'm going to go to the war stories because I'm almost out of time. Paleoentomology is the funny name for the study of ancient bugs. And what this means is, this is a name we came up with when I worked at SGI. It fundamentally comes down to trawling through the version control system to work out who broke something and why. And the reason is it's not a blame storm thing. The point is to discover how it happened, prevent it happening again. And also, more practically, you sometimes need to tell people which releases they need to upgrade from. Git blame -s is your friend. Sometimes you need to manually bisect things. Refactoring and sharp edges. Oh yeah. Sometimes it's so easy to fix something. This is something that actually made perfect sense. So this function returns a string, given the pointer into a buffer and length. Except this this comment is a little bit misleading because in fact this buffer could contain nulls and this thing stops at the first null. I broke email filtering on our service using that. I might go past that one. The infamous May 13 incident. This is a bit of a mea culpa thing for me. So in Cyrus we have this file called annotation definitions, which is almost always, in all instances where Cyrus is actually deployed, empty. Nothing's there. I committed a one-line file because we needed a feature to our internal fastmail config, but not the one that I'd tested. Oh no, there was 1 comma too many.
Luxury of Perl.
The luxury of Perl.
Allowing you to have an extra comment.
Oh no, oh I wish. No, we didn't have that luxury. So somebody later came along and blithely rolled out this trivial obvious change to all the servers at once, all the production servers. They made a perfectly sensible judgment call, I think, except there was a landmine there. So when you start the IMAP server process, it detects this error and calls fatal, which calls exit. And then the master process that runs and controls all the IMAPDs says, oh, you exited during startup. Well, that's no good. I'll start another one. So now you have, as soon as you restart Cyrus, you have a loop which is chewing up CPU, spewing an enormous amount of stuff to syslog, and of course denying you any service. But then it gets better. In Fastmail, we have a patch which changes fatal to abort. So this CPU chewing loop is now a core dumping CPU chewing loop. That's core dumping into the meta partition where the databases live. So a few minutes after the rollout, before anybody could figure out what was going wrong, all the meta partitions on the smallest servers had filled up. And it turns out that our database code doesn't work very well at any no space. So they all got corrupted. It was a several hour outage in which all the databases had to be recovered from replicas and backups. The replicas didn't save us in every single case. No emails were lost, no folders were lost. A bunch of dynamic flags like seen were. Nothing actually dramatic. A few people were confused when they logged in and read email was, less red than they thought it was. Of course, there was no service during the outage, and it took us about 2 days to cross-check all the data and make sure everything. Basically, it took us 2 days to stabilise from this 1 comma. So the lesson here is cascading failures are awful, and commas are very dangerous. And my last war story is weakness, advertising weakness. If you put out a security release which has a CVE number in the changelog, the flies gather. So people come and look at the same code because on the perfectly reasonable idea that because there's one bug, there's probably more. So we released 2.4.11, on the 9th of September. which patched this particular thing, which is you could basically talk to an unauthorized user could talk to an NNTP daemon and crash it, which means you could basically take it over if you're smart. Fortunately for us, we don't run that server, but nevertheless, that code had been in there for 7, 8 years, something like that. So some guy at Secunia noticed this and started digging around on the same code. And a few days later, he comes up with the with the other bug, which turns out that the authorization didn't work properly. And you could convince the thing by walking halfway through the auth procedure that you were authorized. So, yeah, which basically meant that you could then trigger the other bug. Oh dear. Yes, so 2.4.12 followed very, very soon thereafter. It's an important lesson. Don't expect any security fix to be the end of a problem. It's only the beginning. I think I will give you a brief taste of how much more stuff we have to do. Thank a bunch of people. There's a whole bunch of references of people who read the slides. And last of all, we're hiring. If you like Perl, there are jobs in Melbourne or Oslo. Your choice. I would choose Melbourne personally, but that's, my taste. Okay, questions?
Yes, any questions? Actually, I'd like to start first with a question.
Oh.
And I've got the prerogative of holding the microphone.
It's your privilege.
When you're looking at renovating some new package, I mean, there are many different things you could do. There are features you might want to add, the code structure you might want to change. If it's not C, maybe you want to turn it into OOP sort of code. Many, many things you can do. How do you decide what it is you're going to tackle first, and how do you prioritise those sorts of things?
Choosing and prioritising. Well, I fix the ones I find first. Each of the finding procedures is usually sufficiently complex that I say, well, today I'm going to grep for realloc, and for the next week I'm going to fix all of those. That's more or less a randomly directed process. I also use this kind of work as a distraction from the feature work, as in, oh, I'm bored with creating conversations today, I'll go and fix some reallocs. So that isn't really much of an answer, I'm sorry. I don't think you really should prioritise this. I mean, having enough time free in your schedule to do cleanup work is good, but it's not like janitorial work should be part of your, on your roadmap. Nobody's going to buy things for that. Anyone else?
Yes.
Have you ever heard of Coccinelle? That it's a transformation. It's an analysis and transformation program from a French institution.
I'm sorry, what's the name of it?
Coccinelle.
Coccinelle? No, I haven't.
It's used in the Linux kernel and find a lot of, kind of few bugs.
Right.
And basically, it'll allow you to define patterns. Right. And then you run this through all your C code. And you can also define transformation for this pattern. So he also give you a kind of patch that it's, of course, it looks at variables and it can match a lot of simple mistakes.
That sounds enormously useful.
Yeah, Coccinelle.
There's about 4 or 5 different static analysis tools. There's that one, there's Renovating, there's Goanna, which is a homegrown thing.
It seems like to do a lot of grep and hand analysis instead of using this.
I agree, grep is boring.
Next.
Clan?
Clang is like sort of static analysis.
A C-lang. Oh, okay, yes. Yeah, there are many. I mean, use one, use them all. They're all great. Anything that actually finds bugs is a good thing.
So would you be crazy enough to try and compile this up as 64-bit?
We run it in production in 64-bit.
Right. Did you have problems, presuming it was written as 32-bit code?
A few years ago. We fixed them. No, we actually do need this because we converted over to fully 64-bit production last year. We'd been running that in testing for a while. So when we went to Squeeze, we run Debian boxes for production. We went to Squeeze, we went to 64-bit Squeeze. And There were a few little problems, but the ability to actually map files that we generated, that's good. Anyone else? Yes?
Is the result now better than Dovecot, do you think? Or if you had a choice? Just a disclaimer, I've got to choose a pop mail for an ISP.
Fair enough. That's a loaded question, and I'm not objective enough to answer that question. I might have chosen Dovecot had I started from scratch when I joined this company. On the other hand, the thing about the Cyrus thing is it is actually kind of fast when it works. It doesn't have plugins, which means it's really awkward. Adding new features gets really, really complicated and interesting. On the other hand, it mostly works, those bits that are actually there. So, I don't know, your choice. I would suggest that you try them out and see which one works for you.
Thank you.
I work on Cyrus. That doesn't necessarily mean that I think it's the best thing on the planet. I'm just too ignorant of Dovecot to really answer that, sorry.
Do you ever look at like design level bugs, or looking at things from the top down rather than...
Yes, we do. We do look at design level bugs. In fact, one of the things that has happened over the last couple of years is Bron has redesigned a whole bunch of stuff to do with mailbox handling. That entire lump of code that handled mailboxes was really broken. And the very next thing that we're doing, which is actually on my remaining work thing, is a new message API, which is doing the same thing for actually handling messages. Again, it's because the code was old, nobody really designed it or thought about it, and a whole bunch of features got added after the fact that didn't, from RFCs didn't exist when it was written, so, yes, we do look at design level stuff. We have about 3 minutes, I believe.
In regard to the question about Dovecot versus Cyrus, I'm not going to criticise Cyrus anyway. One thing about Cyrus is that it owns your mail. It does its own thing. You can't do other things with it. Cyrus does everything, delivery and reading via POP and IMAP.
Yep.
Dovecot works with other things. So you can have postfix to delivery, Dovecot reading. You could have you could be using Dovecot, then say, I want to switch to Courier, and just put the Courier program in there and use the same mail spool.
Well, we use postfix as well.
Yep. Well, postfix can call a Cyrus delivery program, but it's all controlled by Cyrus.
Well,
and that theoretically gives a performance benefit.
I'm sorry?
It theoretically gives a performance benefit.
In theory, yes. Yes, like I said earlier, it's kind of different philosophies, and although calling Cyrus's behaviour a philosophy is possibly a bit of a reach. Calling that a philosophy, that would imply it was deliberate. Anyone else?
Last question.
Did you find when you started the project up, I suppose your company took the project under their wing, that you got contributors who were new to it or who had previously been waiting to someone?
We got new contributors. We got new contributors for two reasons. Firstly, because people saw that there was an active community, and that gives people the confidence to try it. The confidence that if I have a problem with it, my bug will be fixed. This is one of the reasons why having the modernisation program is actually worthwhile doing. And we also got it because we took the effort, and I'm talking about Bron here when I say we, Bron took the effort to actually be on IRC, be on the mailing list, talk to people, answer their questions, take their patches, be grateful for them, do all the stuff that a wonderful benevolent maintainer does, which had kind of fallen by the wayside because the people who originally wrote this had other things to do. They moved on, that's the way it works. Yes, it's worth it. You get new developers. Having new developers is usually a very good thing. Almost all the time, 99% of the time, a very good thing.
Okay, Greg, on behalf of the Linux conference, I'd like to present you with a little gift as a glass penguin.
Joy.
Made in Ballarat.
Excellent.
So would everyone like to thank Greg, please speak. Thank you.